Hello guys, today we'll be talking about one of the very basic design patterns in the Hoops world, which is called Singleton Design Pattern. So focusing on what is actually a Singleton Design Pattern. So as the name suggests, it is helpful when we want to initiate just one instance of a class. So let's say if this is my class, which is app, and I just want one instance of this class to exist throughout my application lifecycle, then I would use a singleton design pattern. It's commonly used in sort of databases and services when you don't want any other class to start reproducing the objects for their local reference. It also restricts further initialization because, like I pointed out, if there is a database object that exists and you can query your database using that object, you don't want some other class to start initialization. You want to ensure that that singleton pattern is maintained throughout your application lifecycle. And we'll all at the end we'll also be looking at lazy versus eager initialization patterns, which is sort of an extension. So let's just get started. So let's say I want to design a class. Let's say this has to be static class because it's a nested one. I'll just call my class singleton, and let's say I have a few fields here which I can omit. There's a constructor to singleton. My singleton is a class name. There's a constructor to it, and I have a method called get instance. So if I'm doing a get instance, I must return the same thing back and make it public static. And what I return is I create a variable called instance here. Let's say I would make it private because I don't want somebody to be directly accessing it. It can, let's say, be it can be null here to start with. And when somebody calls get instance, okay, so let's proceed with new singleton. This we are initializing at the beginning itself using the constructor. What we do is we return the instance. Return instance. Why can't I return this? Okay, this is not static. This has to be static because we want just one single instance of the class singleton. So now what this is doing is this class contains a self-reference, which is an object called instance. We are initializing it and using this constructor. And whenever somebody does a get instance, we return that instance. Very straightforward. And let's say if we want to we want to reference it via our main class. Let's call it S1. What we do is we do a singleton dot get instance. And to show you a good example, let me just reproduce this multiple times. S3, S4. And how do we ensure that these are the same references? Okay, so let's just run this now. So when we run this in debug mode, you'll notice that they would be pointing, since this is a pointer, it is pointing to the same memory location. If you can notice this, what I'll do is I'll print this out as well. So this is 4, and yeah, so if I just simply print this out, let's see what it prints. See, printing the same memory block for all the objects. That means we were able to achieve the singleton design pattern. To also give you an insight about this, let's check the memory block also. See, singleton is just initiated once. This class just has one count. That means it just has one memory block allocated to it. And to do the other way around, let's just use a constructor now. New singleton. This would basically, this is a sort of an anti pattern now because we are sort of initializing using the new, but let's see, this should give me memory as 2 and a different address block. See, it's 467, 468. And let's just check this one out. Singleton count is 2 because we've sort of initialized 1 not using the singleton design pattern. So how do we stop users from doing this? So now, since I mentioned, we've already done this. We have achieved this agenda, which one instance of our class using this method called getInstance. Now we also want to restrict the user from further initialization. What we do is we make the constructor private so that only this class knows how to initialize this, because I don't want now this should go away ideally, because you'll have these spanning across classes and it will not be within the same class. Now since I've made it private, nobody apart from this class can do this. So just to give you a better example, I'll just create a singleton class here. I'll just copy this code and get rid from here. So this is, again, don't don't get confused. I'm just separating things out. So now this is private, so I just don't need it anymore. Now if I do singleton s5 and do a new singleton, I can't do it because it has a private access. So only this class knows how to initialize it. So we have kind of achieved our second objective too, that restrict further initializations. If somebody wants an instance, they have to use this method, which is not going to create a new one. So moving on to the next objective, which is lazy versus eager initialization. This is quite a good thing to know, and most of the folks often skip it. So this instance at the time of class loading, so in when the classes were getting loaded to your JVM, we have sort of initialized this variable at the beginning only. So what if we don't want it? What if this is a lesser accessed class and we might not ever need it in the lifecycle? What we can do is we can start with a null, and whenever somebody wants an instance, that is when we will check if our instance is equal to null. Then what you need to do is instance is equal to new singleton. So now blocked a we have added a block here in the get instance. To begin with, this does not have anything. This is a null empty object. Whenever somebody, so whenever I'm doing a first get instance, that is the time when instance would be initialized, and every time else apart from the first time, we would just keep returning because this instance has been done. So let's just run and double check if it's working fine. Yep, it's working perfectly as we wanted it to. And but here one catch that I missed is it also has to be thread safe, because most of the times your applications would be running in multiple boxes and all of those things in multiple JVM machines. So you want it to be thread safe, that in a single, I'm sorry, I kind of did not make it very clear. Let's say if your application is running on a machine, there are multiple threads which are trying to access resources, but you want it, all the threads who are parallelly wanting to get instance, if they enter this block at the same time, they would end up creating they would try to initialize it twice. We don't want that to happen. So the easiest thing that we can do is we can add a synchronized keyword here. What synchronized does, it does not let multiple threads access the same method. Got it? So this is just a additional uh, reference for you guys. You can just know these things beforehand. And to give you a good example, I can just create a class for you, which is maybe my service. Just calling it just to give you a very quick insight how this is being used uh, in reality. So this is the database. So this database object just has to exist once. And let's say I have a get instance and this returns a database, and this has a constructor too. So repeating the same block here, if my instance is equal to null, instance is equal to new database, and uh, why do I need this constructor does not have to be just you can initialize maybe whatever fields that you have, and in my service what I need to do is when I am accessing my database object, this is my database. I don't do a new database anymore because now I want to make it private. I want all my services to be using my data database dot get instance method. Is it not public? It's public but not static. And this also has to be static, guys. Just be very sure of these practices. And you can have any logic in your service that deals with database.get, database.update. Everything is just using one instance. So just giving you an example of how this is being used. And in case, guys, you face any problem in understanding any of this concept, I'll be pushing more content about the best design patterns that you would practically use in your day-to-day coding. Just drop in a comment if there's a specific design pattern that you want clarity on, and I would love to video on it. Thank you so much, guys, for watching. Stay tuned for more.